Hello, and welcome to Nebula Explained. This is a free preview section to promote the full Udemy course. Please go to www.learndigitalaudio.com/nebula for full details on what packages are available and how you can sign up right away. This free section of the course is the first of 2 chapters on the very important subject of gain staging. Today, we're going to learn about what is gain staging, what are the basic concepts of gain staging, and why is gain staging so important for Nebula. We will learn how to set the ideal input level to Nebula, giving plenty of headroom, triggering the dynamic layers, and driving the saturation to taste. So, what is gain staging? It is simply optimizing the volume the audio passes through your recording chain. Anywhere in the recording chain where you can turn the volume up or down can be considered a gain stage. It's important to remember in the digital world this includes volume levels inside your DAW and its plugins. What are the basic concepts of gain staging? In analog and digital recording, you should record a loud enough signal to have a good signal to noise ratio and enough headroom so there's no danger of distortion or clipping. Headroom is the space between the current level of the audio and the maximum it can be. Here is a diagram to illustrate the difference between no headroom and plenty of headroom. We want a signal that's loud enough to not suffer from excess analog noise or have to be needlessly turned up in the DAW. It must not be so loud that when we sum many tracks together it clips the DAW. Here's an example of a typical signal chain. First we have the microphone. This outputs a very low signal. We need to boost this with a preamp. This line with an arrow represents the signal flow. So the microphone signal comes into our preamp and enters its first gain stage. How much gain should we use? This will directly affect its output level and in turn the input level of our next stage, the sound card. The next stage in our chain is our sound card line in. We want to get a healthy signal in to minimize the background noise from our mic and preamp. What would it sound like if our preamp gain was too low? Let's listen. Here is my voice recorded at a good gain level. Here is my voice recorded at a very low level and boosted back up again digitally inside the DAW. You can hear all the annoying background noises from the analog stages. Sounds really bad. We have to consider that there are probably going to be many different tracks recorded into our project that will be summed together to create our final mix. Let's say we turned the gain right up on the preamp and recorded very loud, almost to the point of distortion. The output signal comes into the sound card hot, but it doesn't clip the converters. Everything would seem okay. What if we record everything at this level and sum it together? The result would be the DAW output clips. The whole system is overloaded. We could go in and turn every track fader down, but that'd be a huge waste of time and also cause additional problems for a plugin like Nebula that emulates analog equipment. Why is gain staging so important for Nebula? Gain staging is so important for Nebula as its dynamic programs behave exactly like the analog hardware they were sampled from. They react differently when fed with different volumes of audio. It's not just that we need to avoid overload or insufficient signal levels. There are several key things we also need to understand when thinking about the volumes of the audio we send to Nebula. If input is too loud, we will get digital overload. This results in very bad sounding artifacts. Here is a copy of Nebula running the NAG tape emulation program by STN. Let's see what happens when we overload it. Watch the overload indicator here. The sound breaks up before the overload indicator comes on. It's obvious we don't want to overload Nebula, but not so obvious why we don't want to underload it. Dynamic programs are different from other types of programs in that they have many sampled layers for different levels of input volume. If the input is too quiet and it is a dynamic program, we may not trigger the sampled dynamic layers. We will lose the 3D effect. For example, a spring reverb may get a splashier sound the louder the input. Here is a diagram to show how Nebula's dynamic layers work. The red dotted line shows how the envelope follower tracks the volume of the incoming audio. The envelope follower has its own settings to exactly how it is doing this, and it can be found on the EVFS page. Each number on the line represents when Nebula takes a reading of the volume. The interval between each number represents the prog rate. The prog rate determines how often the envelope follower takes a volume reading. The faster the prog rate, the more accurate the emulation. It can track the changes in the audio more accurately. If we start to follow the audio from the first sample, we can see how each reading corresponds to playing a different dynamic layer. These dynamic layers store the sound of the original sampled hardware at many different volume input levels. For example, if you play a louder sound into it, then you will hear exactly how the original hardware sounded to a louder input. This is the secret of Nebula's amazing emulation. For example, sample 1 is relatively high and triggers dynamic layer 2. Sample 8 is very low and triggers dynamic layer 6. As the sound is played, Nebula interpolates between the different layers. The way it does this is determined by the smooth algorithm used. This is shown by the red line crossing the dynamic layers. The important thing to remember about this is to make sure your volume level is loud enough to trigger the dynamic layers you want to hear. Every program is different and must be learned as if it were a new plugin. Usually, the louder the input, the layers with more distortion will be triggered. But too low an input and there will be no interpolation between layers and no 3D sound. If the preset has distortion kernels, the louder the input, the more distortion we will hear. This is simply because we're triggering the layers with more distortion. Ideally, we want to listen carefully and alter this effect to our personal taste. How much distortion is possible depends entirely on how the program was sampled and from what hardware. Unfortunately, it's impossible for Nebula to reach extremely high levels of distortion because of technical restrictions. If we want that effect, we'll have to use another plugin. Having said that, there are some programs that can reach high levels of distortion. Let's take a look at one of them. SCS Treble and Bass Amp EQ by Tim Petherick. This program is sampled from a vintage 60s Selmer guitar amp. It has an EQ control for treble and bass along with input control and saturation level. The input control is the same as the GDRV, aka G drive, on other programs. It's the same as turning up the input to Nebula at the same time as turning down the output. The SAT control is the same as the one usually called drive. It turns up the harmonics to create more distortion. Every Nebula program is sampled in a different way. What works well for this program may not work well on another. Let's listen to how much distortion we can achieve with this one. As we turn it on, we hear a slight smile EQ. Here is the EQ plot with the treble and bass control set to 0. So leaving the additional EQ settings alone, let's listen to the unaffected audio. A mildly distorted, weak, flat-sounding soft synth. Okay, it sounds terrible. Let's try and breathe some Nebula magic into this lame loop. Let's now listen to it using the SCS program with all its controls flat. Remember, it has a mild smile EQ built in. You'll be hearing a little bit of extra bass and treble. Now let's add some saturation using the SAT control. Let's flick between 0 and 30 a few times to easily hear the nice distortion we're starting to add to the signal. And now add some drive. We have hit the program limit and it's starting to fall apart. Let's pull that back a bit. That sounds good there. Now let's check the RMS with Nebula off so we can make a perfect volume match to hear our results in context. Minus 20.9 dB on the left-hand channel. So let's reduce the output a bit to compensate. Check the RMS, almost spot on. Let's flick between them and make our final judgment. Sounds excellent. Summary. Gain staging is simply optimizing the volume that audio passes through your recording chain. It's vital for Nebula dynamic programs as they behave like analog hardware. They react differently when fed with different volumes of audio. Too loud and we get artifacts. Too low and we lose the 3D sound. In between, we control the amount of saturation. We can use the GDRV or equivalent control when available to perform quick gain staging, but drive control increases the distortion, but the results do not always reflect the original hardware in many programs. Every Nebula program and sound source being processed is different and needs to have the gain staging set by ear. There is usually an input volume sweet spot where we are emulating the hardware being driven at just the level the third-party developer intended us to use it at. Luckily for us, many developers have already given us a visual way to easily find this level using freely available metering inside your DAW. In the next section, we will set up our DAW so that every track is at the same volume level before it hits your track faders and insert plugins. This will allow all the Headroom Nebula needs to operate at its best and will automatically make the volume levels coming into Nebula just where you want them to be. If you don't already have a gain staging system in place, you will probably change the entire way you use your DAW for the better. The magic formula, which may seem meaningless now, is minus 18 dB FS RMS equals 0 dB VU. In the next section, we will find out exactly what this means and how to set up your ultimate gain staging system for Nebula and your entire DAW-based studio.